Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 12 mathematics and a 3D trigonometry and the application of the cosine rule and trig ratios in this examination question. This question appeared in the November 2018 paper 2. It reads as follows. It says a pilot flying a helicopter at point A, which is h meters directly above point D. On the ground, he notices a strange object at point B. The pilot determines the angle of depression from point A to B is 30 degrees. He also determines that the control room at point C is 3h meters from A, and BAC is equal to 2x. Point B, C, and D are in the same horizontal plane. The scenario is shown in the diagram below. Everything that I just read is in this diagram here. There's the helicopter here, alright? And you can see 30 degrees is the angle of depression, and AD is h, BAC is 2x, and AC is 3h. Now, let's see, what do they want us to find? First question says, determine the distance AB in terms of h. So let's go and look at where is AB and where is h. So if you look very carefully, you'll be able to see that side AB is that side there, and there's H here. And it's a part of a right angle triangle. Therefore, in a right angle triangle, remember to use your trig ratios, SOHCAHTOA. So we're going to use our trig ratios here. We got the angle of depression is 30 degrees. And remember that this line here is going to be parallel to that. Stay in the same horizontal plane. Angle of depression is equal to the angle of elevation, so that's 30 degrees. So therefore we have a reference angle, which will make h the opposite side, and the side opposite the 90-degree angle will be the hypotenuse, and the remaining side will be the adjacent side. So using our trig ratios now, we can now see h and AB is opposite over hypotenuse, so therefore that will be the use of the trig ratio sine. So we're going to say sine of my reference angle, which is 30 degrees, is equal to the opposite side, which is h, all over AB. AB. Therefore, AB is equal to h over sine 30. H over sine 30. AB equals to, so h over sine 30 will be h over half, and h over half will be 2h. So therefore AB equals to 2h. So now that we know that this whole side here is 2h, we can now go and look at the next question. In the next question it says, show that the distance between the strange object at point B and the control room at point C is given by BC equals to h times the square root of 25 minus 24 cos squared x. So therefore they want us to find this distance BC. So if you look at it very carefully, what do we have? Well, we've got the following. We've got 2h, so we've got this whole side AB. And we've also got AC, which is equal to 3h. They want us to find BC, which is the side opposite this angle, which is 2x. So if you look at it carefully, we're going to be using the cosine rule because we've got two sides, which is 2h and 3h, and we've got an included angle. So therefore our formula will look as follows. Remember, the cosine rule is as follows. BC squared is going to equal to AB squared, which is basically 2h, plus AC squared minus 2 times AB times AC times cos of this included angle, which is A. So cos of angle. So if we now substitute, we get AB squared, it's going to be equal to 2h all squared plus AC squared is 3h squared minus 2 times 2h times 3h times cos of 2x. And then we can solve that, simplify it, and we should get BC equals to h times the square root of 25 minus 24 cos squared x. So now that we've looked at this problem, let's go and write our solutions down. So 7.1. I've already solved it here, so let's write it again. And once again, remember, when working with a right angle triangle, make sure that you look for your reference angle. Side opposite the reference angle is opposite side. Side opposite the 90-degree angle is your hypotenuse. The remaining side is your adjacent side. And no SOHCAHTOA. So let's look at that one more time. We'll write sine of 30 is equal to h over AB. H over AB. What did we write after that? So h over AB. Therefore, we're making AB the subject of our equation. We'll say AB is going to equals to h over sine of 30. And we know that sine of 30 is a special angle. So that's going to be h over half, which is equal to 2h. Therefore, AB is equal to 2h. 7.2. Once again, they ask us here, show that the distance between the strange object at point B and the control room at point C is given by BC equals to h times the square root of 25 minus 24 cos squared x. And what did we say in our working? Well, we said that in a non-right angle triangle, we're going to find the opposite side of the reference angle here, which is 2x, or the included angle. We've got two included sides, then we're going to use the cosine rule, which is as follows. So therefore, the formula would be BC squared So if you look very carefully, don't forget cos of 2x is a double angle, and we'll deal with that a little bit later on. 2h all squared is going to be 4h squared plus 3h all squared is 9h squared. Minus 2 times 2h times 3h will be 2 times 2 is 4, and 4 times 3 is 12. So that's negative 12h squared times cos of 2x. Simplify. 4h squared plus 9h squared is 13h squared minus 12h squared times cos of 2x. So BC squared. Now comes the point where I need to look at what expansion am I going to use for cos 2x. So let's go look at the question. It says here that cos squared x. So therefore I need to look for an expansion with cos squared. Now remember, cos 2x is cos squared x minus sine squared x, or we can say 2 cos squared x minus 1, or 1 minus 2 sine squared x. Therefore, which expansion will we use? Well, we've got cos squared x, so therefore the expansion that we'll use is 2 cos squared x minus 1. So let's substitute that. So we have 13h squared minus 12h squared into 2 cos squared x minus 1. 2 cos squared x minus 1. 13h squared. Open the bracket here. We'll get minus 12. H squared will be, times that will be minus 24 h squared times cos squared x minus 12h squared times minus 1 will be plus 12h squared, which leaves us with 13h squared plus 12h squared is 25h squared minus 24h squared times cos squared x. Simplifying further, what can we see? We can remove h squared as a common factor. So therefore h squared into 25 minus 24 cos squared x. Now don't forget that this is all bc squared. So therefore, if we take the square root of both sides, we are going to be left with the square root of this whole thing here will give us h times the square root of 25 minus 24 cos squared x. Let's go and compare our answer with what was given. BC equals to h times the square root of 25 minus 24 cos squared x. And as you can see, it is the same. Learners, if you haven't subscribed to my channel, JL Maths, please do subscribe and share this content as much as possible with your friends writing exams. It may help them in some way, shape, or form. Also check out all the videos on jlmaths.com. Like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.